Let's investigate the quantum of the decay of the tau lepton, specifically the electric charge, spin, and the weak charge. First, the electric charge. And if we look at the composition of the tau lepton, the generic neutrino, and the scalar boson minus, we'll see that on the generic neutrino, the electric charge is 0. But on the scalar boson minus, the electric charge on the respective particles is minus 2/3 and minus 1/3, which sums to minus 1 for the electric charge. And if we look at the anti-tau lepton, we'll see that for the antineutrino, again, we have electric charges of 0 on the composing particles, and on the scalar boson plus, we have the opposite charges, plus 2/3 and plus 1/3, for a total electric charge on the tau lepton of plus 1, which is indicated by the standard model. Now, if we look at the decay products, we can look at the tau neutrino, and we'll see now that we again on the generic neutrino, we have electric charge of 0. And now on the scalar boson 0, we have the electric charge on the component enrichons of plus 1/3 and minus 1/3, which gives us also 0. So the total electric charge on the tau neutrino will be 0. Now, if we look at the vector W boson, we first have the vector boson 0, which again has a particle and an antiparticle, which are giving us electric charge of 0. And then on the scalar boson minus, we have on the respective particles minus 2/3 and minus 1/3, which gives us minus 1 again. And so the electric charge is minus 1 on the vector W boson. Now, if the vector W boson interacts with the anti-tau neutrino and gives us an anti-tau lepton and gives us an anti-tau neutrino, we will have the particles with the 2/3 charge will mutually annihilate and will leave us only the particles with the minus 1/3 and the plus 1/3, which will give us contributing electric charge of 0. So on the anti-tau neutrino, we will have an electric charge, or total electric charge of 0, as is indicated by the standard model. So now, let's take a look at the spin. And so, the spin on the tau lepton, initially on the generic neutrino, we have minus 1/2, plus 1/2, and minus 1/2, giving us a total of minus 1/2 contribution by the 3 virions. And then we have the contribution of the components of the boson minus. We have a 1/2 and a minus 1/2, giving us a contribution to the spin of 0. So the total spin on the tau lepton will be minus 1/2. And for the opposite anti-tau lepton, we will have 0 contribution again for the boson plus, and the opposite contribution of spin on the anti-V rishons, so that the spin of the total spin for the anti-tau lepton will be plus 1/2. Now, there is an exchange of particles in the decay that will lead to a spin 1/2 total on the neutrino. And so that the tau neutrino now, in combination with the boson 0, which also contributes a spin of 0 because it has plus 1/2 and minus 1/2 on respective components, will now be plus 1/2. Whereas for the vector W boson, the vector boson 0 now, its components will have minus 1/2 and minus 1/2, which will give a minus 1 spin. And the boson minus now will have on the respective components a minus and plus contributing 0, but the total spin for the vector W boson will be minus 1. Now, if we look at what happens if this vector W boson combines with the anti-tau lepton, we'll see again that these particles, the V prime and the anti-V prime, will now mutually annihilate, and will leave these two components, which also have a spin components that are oppositely signed and contribute nothing to the spin. And so the total spin would then be, the contribution of the spin will only be given by this minus 1 spin vector boson and this plus 1/2 spin of the anti-neutrino, leaving a minus 1/2 spin for the anti-tau neutrino. So now, let's move on to the weak charge. So the weak charge, given that this was a left-handed neutrino, according to the standard model, we should have a plus 1/2 weak charge. And we can see that 1/3 plus 1/3 is 2/3, or 4/6, minus 1/6 gives us 3/6. And so that is a plus 1/2 on this left-handed neutrino. But the entire composition of the tau lepton having a spin of minus 1/2 actually must have, according to the standard model, a weak charge of minus 1/2. And if we look at the weak charge contribution of these components of the boson minus, we'll see that we have minus 1/3 and minus 2/3, which gives us minus 1. And minus 1 summed with the plus 1/2 will give us minus 1/2 weak charge on the tau lepton, which is consistent with the standard model. And we'll find that we have the opposite weak charges on the anti-tau. Now let's look at the decay products. And so, as we indicated earlier, the spin on the generic neutrino changed from left-handed to right-handed. And so, according to the standard model, we should have a 0 weak charge. And we see we have minus 2/6 plus 2/6 is 0. And the contribution on the boson 0 here is minus 1/3 and plus 1/3, which is also 0. So that the weak charge of the tau neutrino will be, right-handed tau neutrino will be 0 as predicted by the standard model. Now, if we look at the vector W boson, we have on the vector boson 0, we have 1/6 plus 2/6, which is 3/6, which is 1/2 weak charge. But on the boson minus, we have minus 1/3 and minus 2/3, which is minus 1. Summed with the 1/2, we get a minus 1/2 weak charge on the vector W boson, which would be indicated by the standard model because it's the minus 1/2 that was carried away in the decay process. Now, if we look again at what happens when this W boson interacts with the anti-tau neutrino and changes it into the anti-tau lepton and changes it into an anti-tau neutrino, again we have the mutual annihilation of these two, this particle and antiparticle, leaving you these two particles which have a minus 1/3 and 1/3 weak charge, which sums to 0. And so the weak charge for this left-handed will be given by a 1/2 weak charge on the vector boson 0 and the minus 1/2 given by the anti-neutrino, generic anti-neutrino, those canceling each other out, so that the weak charge will be 0 on the anti-tau neutrino, the left-handed anti-tau neutrino, which is predicted by the standard model. And so there we have a review of the quantum of the tau lepton and its decay products, of the electric charge, the spin, and the weak charges, and see that they are consistent in this Rishon model with the standard model.